First of all, before watching this video, please make sure to watch that video. I explained something important there that's related to this build.
When using a motor for the steering wheel, the torque of the motor is very important. And rotating the larger pulley through it, the torque can be increased.
In this video, I used some parts from the local market and some from online stores. I've added links in the description for the parts one bought from online. Let's get straight to the most important part of this project. For a low-budget setup, I chose the RS550 DC motor. Most DIY wheels use a 775 motors, but the 550 is cheaper and still works well. Also, it has a bit less power than a 775 motor. That's the cheapest and suitable motor for this project. There are different versions of this motor with different torque and RPM, so make sure it has high torque. Two important things when choosing this motor. First, make sure it has a built-in cooling fan, because this motor can easily generate heat while working. You can see my motor doesn't have a fan, so this is not a great idea to use this motor, but my only purpose is to show you how to make this. Second, the metal ring around the motor. Some people call it a magnetic ring, and it helps improve the magnetic field. I don't know if it's true, but it helps to reduce the heat of the motor. So that's also important to have it. Now for the pulleys. I'm using a GT216 tooth with a 3mm bore pulley for the motor. And I use a GT260 tooth with an 8mm bore pulley for the wheel shaft. Using a smaller pulley on the motor and a bigger one on the wheel, the torque will increase. If you can, go for an 80 or 120 tooth pulley for even better torque. On a tighter budget, a 40 tooth pulley will still work, just with less power. For the belt, I'm using a 300mm closed-loop GT2 belt. To control the motor, I'm using the BTS7962 motor driver. There was no other module that matched this, so we had to use this. This is the motor bracket. This will come with 2 bolts for the motor, and I slightly enlarged these holes to use bigger bolts. For cooling, I'm using a blower-style fan. You can use a regular fan, but I chose this because this fan can point the airflow. So I am planning to directing airflow right through the motor, because the motor is starting to get hot from the inside. And the main reason is that my motor doesn't have a built-in fan, so use a normal fan if you have that. Then we need male-to-male jumper cables and male-to-female jumper cables. And I used a breadboard also. In the next video I explain how to wire this step by step. If you're new to electronics, that video will be very helpful for you. You may remember when I mounted the wheelbase on the table, this happened. Then I drilled just a little deeper using a bigger drill bit. But that also didn't work because my wood board is too thin. So that's why I did this. I glued another board like this and cut holes to put bolts in it. Recently I recorded another video, so I made some changes here. Okay, let's assemble this all. The next problem is that my 16T pulley does not fit the motor. So I have two options for that. First one, enlarge the pulley hole or reduce the motor shaft diameter. So I choose the second option, because if I try to enlarge the pulley, maybe it's not balanced when rotating. I will supply the voltage to the motor, then use sandpaper to cut the shaft. This is a steel wall mounting bracket. I bought it from a local hardware store. If you can't find it, you can use something similar. Actually, this belt tensioner is not mandatory. You can just adjust the motor bracket. But I use it because the belt gets loose over time. So this belt tensioner can easily adjust that. I use a 12-volt 20 ampere power supply, but this motor takes 10 to 15 amperes of current. I will explain about the power supply at the end of the video. After connecting, go to the EMC settings. Then choose the 2 PWM plus 1 direction. Now check if the wheel direction is working correctly. When rotated to the right, it should be positive values, and rotated to the left, it should have negative values. You see, mine isn't like that, so I'm switching the encoder signal wires. Now it's fixed. Then, check the force feedback direction is correct. You have to carefully turn the wheel to the left side to cross the wheel limit. If your wheel tries to spin in the same direction you turn, you have to change the feedback direction. You need to swap these two wires on the motor drive. I will suggest using 50% of soft lock. It's better if you don't use it, because it makes motor more heat while playing. Now I will run the FFB test using the wheel check application. I do not recommend testing for a long time, because the motor gets extremely hot while running. Okay, now check how it works in ETS2. First, I will adjust a few feedback settings. I use force power like 100% and bumps and collisions set to 100%. You can see the wheel moving a bit. I will increase it more and set the power to 130%. It's better than before. Now I will increase the power to 150%, then set this all to 50% to see what happens. This happened because of the engine response. I think 150% better for this. I can feel the road bump strongly. Also, the wheel has good mechanical friction. Next, I will show the temperature of the motor and driver. And let's see how much power it consumes. I have a dual temperature sensor module, and this one can measure the current. This module can only measure a maximum of 10 amps. I install one temp sensor on the motor and the other on the driver. I have set up both modules now. The green one is a motor temperature sensor. You will see that it is increasing. The current is already showing 0.2 amperes because of my cooling fan. First, I will run a test using the wheel check application. You can see it's taking more than 10 amperes now. Let's see how the temperature is. It starts to increase little by little. The test has now stopped, but it keeps increasing. After 1 minute it gets almost 49 Celsius, then it gets down by little. The BTS driver temp is normal. A motor like the one I mentioned earlier probably wouldn't get this hot. Remember that the motor will draw full power during this test process. That's why I'm telling you not to use this test for too long. Let's see what happens when playing. This is the force setting I currently use. I've been playing for about 30 minutes now, and the maximum is about 36 Celsius. In this game, it can be played without any issue. Let's see how it works in F122. Actually, this game needs a lot of feedback power. Honestly, this setup is playable, but its power is not enough for this game. Even my 775 motor setup is not enough for this. If the feedback force is not enough, it is difficult to take corners. Also, it's a little difficult to keep the car straight. I use these feedback settings. Like I said before, when cornering it takes around 10 amperes. The temperature also increases. After 2 minutes, it rises to 46 degrees Celsius. The temp is a bit high, but it's fine. I show the temperature and power difference, just to get an idea for you. When adding the steering wheel to the force feedback, this is currently the lowest budget that can be made. The only thing that is a little expensive here is the motor and BTS driver. If you are looking for an even lower budget, I will say a few things. But keep in mind that it reduces the power a little. This 550 motor is mostly used in RC cars, some toy cars, and cordless drill drivers, so maybe you can find it somewhere. There is no other option for the motor driver, so you have to buy it. A small motor pulley, like 16-tooth or 20-tooth, is not that expensive. But a bigger pulley, bit expensive than a smaller one. So you can use at least a 40-tooth pulley. As a motor bracket, you can find something similar, or you can make one using a metal sheet. For the power, I recommend using a 12-volt 15-ampere SMP power supply, or you can also use a PC power supply. But check the power rating on the PSU. Make sure it has 12-volt 15 amps or more. I think 10 amps works like ETS2, because you will see that it doesn't use much power when playing. So this wheel setup is better for simulator games like Euro Truck Simulator and Mud Runner. Other games can be played, but like drifting, formula and rally games have little advantage, because the feedback power is not enough for them. So that's it. In the next video I explain how to wire this step by step, and a few videos to come soon. So subscribe and stay tuned.